Assalamu alaikum and welcome back everyone. We continue with the previous topic of how to plot sinusoidal functions in Matlab. So in this lecture, you will learn how to plot two-sided sinusoidal functions using Python. We will study different examples, including half positive and half negative cycle, one complete cycle, and one on the positive side and one on the negative side, etc. This lecture will also explain how changing the plotting range affects the number of cycles displayed graphically. So let's straight away jump to the coding. So let's import required library. So import math, then we import the plotting library, import matplotlib dot pyplot as I think there's some spelling mistake. So this is an import, and then it's a matplotlib. There is no spacing. So as plt. Okay, so the next we will use again toList as in the previous lecture we used. So x for storing the x variable. So we initialize this by this one, and similarly y is equal to this one. Then we use the for loop. So can you recall what we were using last time? Yes, I give you a second. Have a look. So what is the format of the for loop? So in for loop, we use the range function. So for I in range. Okay, now for example, we are going for the half positive cycle and half negative cycle for the cosine waveform or sine waveform. So you understand uh, they both are periodic with period 2 pi. So that means if I start from minus pi to plus pi, then I'll have half positive cycle and half negative cycle. So we use the linear angles, that is the decrease. So in decrease, half pi, minus pi means minus 180 degree and plus pi means plus 180 degrees. So I will say range in, and then I start with the minus 180 degree to 180 degree. And so you understand we need a colon. Okay, this is the format of the for loop. Then what is next? How to proceed? So if you recall from the previous lectures, you understand we will have angle conversion in radians. So let's convert the angle in radian. So for example, angle underscore rad I write is equal to math dot radians, and I give it the input value of say I. Okay, now this returns angle in radian. So then we find the say sine value. So I write just sine value is equal to math dot sine. You can also write the cos value or so, and you give it angle, radian angle underscore radian. So you have this here, then you append, then you write append y dot append, and this is SIN V. So sine value we have appended. Okay, I give you a second. How about the x value? Okay, so for x we will also append the x dot append, and we have the x value, which is angle underscore Right. So now we have both of these. So let's move to the next step, and the next step is the uh, plotting. So you understand we use plt.plot. So I write plt.plot. We have the x, comma, y, and then plt.show. Plt.show, and we are done. Okay, so let's run. So you can run this one. So you see that as compared to the previous lecture, okay, now we have the both-sided. Okay, so sine on negative side has a negative values, and on positive side on positive values. So we have produced the one cycle of this. Okay, let me copy paste to do things quickly. So how about the Control A, Control C, and then I insert the next cell code. You understand this one, right? So how about if I want, uh, say, one complete positive cycle and one complete negative cycle? So you understand, we need to change this range function. Now this is from -180 to 180, that is 360 degrees. Now in case of two cycles, we have 720 degrees. Then I need to change just this one, and instead of -180, I will write 360, right? So 360, and also this one 360, right? So if I just quickly run it, so you understand, now we have got two cycles of the sine wave. Okay, so let's make it more generalized, and I just write to modify the code so that any number of uh, cycles can be plotted. So you understand, if I write here 360 multiplied by n. So n is number of the cycles, and again here 360 multiplied by n. So n is basically the number of cycles we want. You can also take this n from input. So if you like to take it from input, can you recall how we take the input from the user? So you just say n equals to int, and then you write input, and then you just write enter number of cycles on each positive and negative side, right? On positive and on both, in fact, on both positive and negative sides. Okay, so let me write the enter. Okay, so let's this. Okay, run. Now, for example, I want 3 on positive and 3 on negative. So you see the result is displayed, and it consists of basically 6 cycles, 3 on positive and 3 on negative. Now, what if I want, for example, 4, 5, but anyways, you can change it. And also, for example, if you want to plot the cosine wave, so just let me copy paste, Control C. Let's run the same code, but if you want to scale this one, so scaling, you understand, means we can uh, here in terms of amplitude. So you see amplitude reaches to 1. Okay, now if I scale it to the factor of 2, then the amplitude will be scaled by a factor of 2. And how we can scale this one? So this is sine wave, right? So if I write this one, so this is scaling along the x-axis. That means this is called the amplitude scaling. Similarly, we can also have the angle scaling or scaling along the x-axis. So that is done here. Maybe we in next lecture we discuss, or maybe as a homework you can do it by yourself. So let's run this one. So you will see that, for example, I give it two cycles on each side. So you can see previously it was the maximum values was -1. Now it is scaled to 2. So maximum is sorry, most negative value is, our negative peak is -2, and similarly positive peak is +2. So I think I end the lecture here, and I leave some homework for you. So please write Python code to plot the following two-sided sinusoidal function: y is equal to sine x and y is equal to cos x. Okay, so you understand, you have the math library and you can use different function. One of the function is sine you can use, which I have just demonstrated here, but you can also call the cos function and you can plot this one. Okay, so your homework is you generate you generate sine x and cosine x, and for half positive and half negative cycles, one positive and one negative cycle, and three positive and three negative cycle, or maybe let's make it slightly different. So let's um, you make it for say 5 positive. Okay, so let's 5 positive and 5 negative cycles. Okay, so this is for your homework. I think there is some other problem, this one also. So you here it involves scaling, so you understand how to scale this one. Okay, so that's all from my side. So to summarize, in this lecture we learned how to plot two-sided sinusoidal functions using Python, and studied how different angle ranges produce half cycles, full cycles, and multiple cycles, both positive and negative, right? So these concepts are fundamental in mathematics, signal processing, communications, control systems, and also artificial intelligence applications involving wave analysis. I encourage you to practice the homework problems and experiment with different cycles and scales, okay, to better understand how signals behave graphically. So that's all from the my side. See you in the next lecture.